Hello and welcome to another live Q&A session. I'm very pleased tonight to be joined by a couple of our area assessors. Lee Hancock. Hi Lee, how are you? How's your day been?
Hi Sam, how's things? Are you well?
Yeah, I'm very good. How's your day been so far?
Yeah, not bad, cheers Sam. It's been a really good 2 days actually. I've been with a large local authority up in the northeast, so we've got 4 QSs there, and we've seen a right good cross-section of work, 4 excellent QSs, and it's been a really pleasurable couple of days, to be fair.
Good stuff. And welcome to Stuart Kershaw. Stuart, how's your day been and what have you been up to today?
Welcome everyone. Yeah, thanks. I've been over in West Yorkshire carrying out a QS assessment for an additional QS, with a good set of guys really, and girls.
Oh,
But
brilliant.
very positive assessment today. Yeah, very positive, and the CPD, the guys are into there. It shone through, so it was a good, positive, engaging assessment today.
Yeah. No, we were just talking off camera. Our industry is so wide that we're in that very privileged position that we get to see bits of everything. Whereas when we were on the tools in work, you tend to stick in that small parallel that you're normally in. But we get the added advantage of seeing everything from medical locations to solar farms to domestic. It's a really privileged position, and we do get a lot out of it. Okay.
We definitely get into some interesting sites.
We'll make a start. So just before we start, we'll go through the housekeeping. So our team will offer advice and guidance on the questions asked, but the guidance that we give will only be limited by the information in the question. We can't assume any liability for anyone for any loss or damage caused by an error or omission in any advice that we give, whether that error or omission is the result of negligence or any other cause. If we do reference any legislation, it's not to be considered legal advice. And as always, that the big thing is that individuals must rely on their own skill and judgment when making use of any of the guidance offered. So without any more to do, we'll have a look at the question of the week that we posted out on Monday. And Monday's question was regarding SPDs. The question was, for compliance with BS 7671, where is the overcurrent protection with respect to short circuit current for SPDs required to be? Does it have to A, be internal to the SPD? Does it have to B, be external to the SPD? Can it C, be either internal or external? Or D, is that not specified in 7671? And we did have a little look earlier today, so we had a look on the LinkedIn posts just to see, and the LinkedIn posts we had a rough split, but 51%, so just the majority, were saying it was C, either A or B. But what's our answer? I think Lee, you're going to take this one, aren't you? What's our answer on that, Lee?
Yeah, no worries. Nice, straightforward one to warm up with there, Sam. 534.4.5.1 is going to support this, and the protection can be internal or external to the device. C is actually the right answer there. Ultimately, when we're fitting these things, we've got to consider the manufacturer's guidance. We know where they want these things to be positioned within the DB, where they want, if there's external overcurrent protection, where that should be located. A lot of boards nowadays, you purchase them, they're already in. So contractors don't really have to concern themselves too much with this. But sometimes you may be retrofitting a consumer unit with one. And if the manufacturers want the device, for instance, next door to the main switch, sometimes they'll supply leads to connect into the bus bar arrangement, which are quite short, so they sort of dictate where the device has got to be. You've got to consider then where the overcurrent device has got to be. Sometimes that's next door to the main switch as well, which will mean you've got to shunt the other devices across somewhat to get the device in. But yeah, in essence, the answer is C. It can be internal and it can be external.
That's great. Thanks, Lee. So we've got some questions that have hung around from previous editions. Please can I encourage the audience to put their questions in the chat, which we'll get round to. But while we're waiting for some questions to appear, we'll just have a look at some of the past ones which we didn't get time to answer on the night. So the first one of those is what do I need to do to ensure selectivity between RCDs in series? And I think Stuart's going to have a crack at this one.
Yeah, obviously RCDs in series, we need to ensure requirements. So we're looking at upstream RCDs, and obviously two 30 milliamp RCDs in series will not give you selectivity. So therefore we're going to have to look at the regulation 536.4.1.4, which states that as shows the figure 536.2 shows some RCDs in series, and we're looking for a ratio of 3:1. Hence why manufacturers usually are making them at 300 milliamps, 100 milliamps, and 30 milliamps, but also the time delay nature for upstream RCDs. Which again, imperative that we follow manufacturer's instructions on the settings for these S-type devices. Because obviously we've got other regulations in to consider. 314 division of installation, minimising inconvenience in the event of a fault if we have an upstream RCD disconnect at the same time as the downstream, or sometimes, often is the case, before the RCD we want to disconnect. So
yeah, no,
further information, really consult manufacturer's data for setting up of S-type devices, Sam. Yeah,
but it's those things that we always remember, the 3:1 ratio. So upstream should be 3 times the rated value, and
one ratio and S-type for upstream devices.
Yeah. There is a diagram, as you said, that we've just flashed on the screen, just to sort of show you that it's that they try. It's not super clear in 7671, but it tries to show that RCD1 is the upstream device, and then the second level devices are RCD21 and RCD22. So they're the downstream devices that should have the lower rating. Okay, so please do encourage the audience to put their questions in the chat so that we can get round to those. We'll take another one that was held over, and this is quite a common one that we get on the technical helpline. Lee, does the isolator for a domestic bathroom extract fan need to be located next to the fan? Does it have to be next to the fan?
No, it doesn't, Sam. Ultimately, if we're dealing in a bathroom situation, the isolator needs to be external, ideally. 132.15.201 is going to give us a little bit of additional support on this. If we look historically on new builds, fan isolators used to be located above bathroom doorways, just as a means of isolation, not switching. Ultimately, if a fault develops on the fan and we need to isolate it, we can't access that switch. You may find people are going to be using their MCB, their consumer units, which could lead to a further issue then, because you could be putting the place into darkness. So a lot of new builders nowadays specify that the isolator should be at a more localised height, usually next door to a light switch where it's readily accessible. The isolator should disconnect all live parts and live conductors, so it removes all the voltage from the fan, so it's safe to work on. Doesn't pose any dangers if a situation develops. In certain situations, though, the fan isolator might be remote. It could be in a cupboard on a landing, something like that. And where it's not obvious what the isolator is controlling, we need to mark the isolator with a durable label. So it may not be a switch that you operate all the time, but the user's aware that it's there and what its purpose is. So if there is a situation where we need to isolate the fan quickly, they would know through experience of the layout of the building where to head for this and how to switch it off. The identification side of things, there is a regulation that supports this requirement, and that's 537.2.7. And I think that's all we really need to cover on this. It's an isolate it, it's not a switch. The fans normally come on with the lights. So, it's not something that we're going to use all the time, but it's got to be readily available.
Yeah.
We shouldn't need to have to climb on something to gain access to it, if that makes sense. So if it's underneath the ceiling on the landing, maybe that's deemed inappropriate these days. Needs to be at a sensible height.
Yeah. No, it's good, and real key points that you brought out there, Lee, and especially the one that if it isn't going to be local and remote, then we need to make sure that we identify what that isolator is for, because it won't be
100%.
obvious. Yeah.
While we're on the subject, Sam, can I extend on a little bit of information there? And it's something that I come across quite often when we're out doing the assessments with contractors. We all know how to fit these. Predominantly, in a lot of cases, it's a 3-core and earth going to the fan isolator, and then from the fan isolator, another 3-core and earth going up to the fan itself. And for many, many years, contractors have just been using 3-pole isolators, just the standard ones. If we look at the manufacturer's instructions, which I know some days it doesn't happen, we all know how to fit fans, we all know how to connect them up. But if we look at the manufacturer's instructions, in a lot of cases these days, they're requiring the permanent live to be fused down to something more appropriate like 3 amps. And the idea behind this is it's going to protect the motor, or apologies, if the motor was to burn out, it's going to disconnect the supply quickly. It's not going to influence the MCB at the start of the circuit in the distribution board, so therefore it's going to be more localised. If we don't put this fuse in, technically we could be overfusing the fan using the 6 amp device. We're going against manufacturer's instructions there. And if a situation did develop where there was damage to the fan or the building itself, where will the extent of liability lie? Because it's been installed against the manufacturer's instructions. Therefore, we've got no comeback against the manufacturer. And it's down to the electrician who's installed it and commissioned it to accept liability. So for those guys fitting fans out there, it's a little polite request, and it's going to avoid your non-compliance, possibly on your assessment. Take a quick look next time you fit a fan at the manufacturer's instructions. If it needs a 3 amp fuse, putting in a permanent live. We're not allowed to promote brands for obvious reasons, but there are manufacturers out there that supply. Please fit one.
Yeah. Yeah, no, it's a valid point. We do always point out to people that 7671 tells them to consider manufacturer's instructions. So if they've got an engineering reason for not following it, then that should be readily available when we ask the question, have you considered? But yeah, if the answer back is no, we haven't considered the manufacturer's instructions, then they haven't complied with the requirements of 7671.
Mm-hmm. Another point to make on that one, Lee, is 464.4, which is an inherent issue with some of the manufacturers of these devices, that they're not lockable. And the suitable means against inadvertent reclosure when that's another issue possibly with locating them outside of or away from the extract.
Yeah. I have seen a couple of extract fans where you can pop a key into the front of them, Stuart, but I mean, the amount of times I've seen these, I can probably count on one hand.
We're not mentioning manufacturers' names tonight, but we've got a few that are now on board with it and are making them lockable as well. So just worthy to mention that.
Oh, spot on. It's an absolute requirement, isn't it? If they're not local and they're used for maintenance purposes, then they have to be lockable, because you don't inadvertently want somebody switching that on while you've got the fan open and working on it.
This
the whole
takes me
purpose
into
of the switch, isn't it? Mechanical maintenance, switching for mechanical maintenance. So
This takes me into another little topic as well, local isolation. Sometimes you find there's a fan isolator, locally that the consumer can operate. But if it's an inline fan located in a loft, then there should be an isolator next door to the fan as well, so somebody working on it has got complete control over the supply. Maybe they need a live supply to do a test on it, but then quickly need to isolate it so they can remove the fan and work upon it. So it's not only an isolator for the consumer, but there should be an isolator adjacent to the fan itself if it's an inline one, to promote safe working.
Yeah. Okay. Yeah. So please, I do encourage you. I see some people are putting some nice comments in the chat, but let's see if we can get some questions in there as well. Pardon me. We'll take another one that was a hangover. And again, quite a common question that we do get asked. If someone's extending a domestic lighting circuit to supply a mains powered smoke alarm, which is permitted, do they need to add 30 milliamp RCD protection for compliance with 411.3.4? So I think this question boils around, there was a change, and it's fairly recently that domestic lighting circuits have required RCD protection. So someone's come across an incident of a lighting circuit that doesn't have RCD protection. They're extending the lighting circuit to power a mains powered smoke alarm. Do they need to provide RCD protection for compliance with the 411.3.4 reg? I think Stuart is going to help us with this one.
There's two or three different things to consider here, I think, with respect to extending a lighting circuit from a special location, perhaps, or where the zone may extend. But overall, it's minor works, and the answer would be it probably is not required. Well, there is no requirement to provide RCD for a minor works for extending an existing circuit. That we should be looking at regulation 522.6.202, where the cables, it depends how you're going to install those cables. Are they going to be run and contained in the fabric of the building, in which case they would need additional protection. That's clearly stated in that regulation. And obviously we're looking at how we're going to install those cables with that regulation in mind as well. Indent 1 talks about the cables in zones, 250 mil from the top of the wall into the internal corners of the walls, and in lines horizontally and vertically with accessories. So they're fundamental considerations, but the answer is there is no requirement to provide RCD protection just for adding on to a circuit that's existing.
Yep.
Obviously, certification-wise, it would be minor works, and if you're doing the certification correctly, we'd be looking at on our software anyway, is it a DHFN? So we'd be looking at the certification required by 5839, BS 5839 Part 6 for installing a smoke detection device, mains powered.
Yep. Okay. Thanks, Stuart.
And filling those certificates out, can I say guidance is good on the NICEIC Pocket Guides app. Pocket Guide 9, I think, if I'm not mistaken. 9 is the one that will give guidance on the type of system, the grade, whether it's lithium battery. That would be the requirement. But consider 522.6.202, whether it needs additional protection. If you're burying the cables in the fabric of the building, it will do then.
Brilliant. Thank you. So we're getting some questions coming in now, which is great. We'll just take one more that was held over, and then we'll look at some of the questions that have come into the chat. So a fourth one that was held over, should domestic consumer units be installed at a height of 1,200 millimeters, 1.2 meters from the finished floor? And this comes from building regulations requirements for controls being between 450 and 120, but does it apply to consumer units? Lee, I think, is having a look at this.
Yeah. So part M of the building regulations is what we're going to consider now, Sam, accessibility. 1,200, no. Consumer unit is to the level of the switches, that is, 1350 to 1450. Any contractors wanting any guidance on this, I know Stu's just plug the pocket guides there, which I do quite regularly on site visits. Pocket guide number 5 gives us recommended heights of switches, socket outlets and consumer units. It's worth adding though that if we're doing a rewire, we don't have to adhere to that height because the property is pre-existing. It's recommended that we do ultimately, but in some situations we can't. So we're not actually breaking any regulations if we're doing a rewire in an older building, but certainly a newer property, a self-build or a newly developed property, we should be looking at 1350 to 1450. The reason it's slightly higher than the light switches, which are 1200, we've got to consider children. Also, we want children to operate light switches, socket outlets and the likes safely, obviously, but we don't want them interfering with the consumer unit. So it's accessible for somebody who's possibly disabled, or it's accessible for them, if they're in a wheelchair, but maybe it's not quite as easily accessible for a small child, if that makes sense. So they're not liable to, for instance, operate the main switch and put the place into darkness just through playing about.
Yep. Thanks, spot on, Lee.
Okay.
So we'll take a few questions that have come in. So the first one I'm looking at from one of the engineers tonight. When installing Type 1 SPDs without having access to the lightning protection risk assessment and being an electrician not fully conversant with BSEN 62305, who is the designer of the installation on the EIC in relation to the IMAX value of the SPD, even if you have selected the overcurrent protective device and cable size? An SPD and lightning protection system question. My first thoughts are the designer of the electrical installation could well be the electrician, but they may need that expertise from a lightning protection system expert. Alternatively, I think because it's got lightning protection on the property, that tells us that we're going to need a Type 1 SPD as close to the origin as possible. And the other alternative would be to seek guidance from your selected SPD manufacturer with regard to the rating that's required. So it would be the electrical engineer who's the designer as far as the EIC is concerned, because the EIC is confirming, if you look at the declaration on the EIC, that's for compliance with 7671. So that's all you're stating. You're not stating that you're the 62305 lightning protection system designer. You're stating that you're the designer of the electrical installation. So if it's not readily available from the lightning protection system engineer, another alternative might be from your chosen SPD manufacturer. That would help you with IMAX values and the rating of the overcurrent protective device if it's separate from the SPD itself. Would you guys add anything else to that?
Yeah, ultimately, I totally agree with what you just said there, Sam. I know us guys, when we're out in the field, we keep plugging in CPD and the benefits of it. And us guys working for the NICEIC, we're also expected to do it. I've done several on surge protective devices with various manufacturers, and they do offer some excellent CPD training on this, because it is a specialised subject. It can be highly confusing, and as electricians, we just want a straightforward answer. What do we need to do to be compliant with the standards and the regulations? My advice would be, as Sam's just said, consult the manufacturer and see what their guidance is, and do some of their CPD training, because at the end of the day, knowledge is key.
To add to that, really, 534 section of 7671 covers a lot of information about SPDs, but training's key. And the issue that the IMAX level like that would be probably have to be calculated in conjunction with somebody who's a bit more conversant with LPS.
Yeah,
it's British standard 62305. So stick to what you know and design it accordingly.
Yeah. Okay, one perhaps that we're a bit more familiar with. On an EICR test, somebody's come across old 3036 fuses in the consumer unit that have got the plug-in BS 60898 MCBs. So I think they're talking about back in the day, you could get a carrier. Once you replaced your 3036 rewirable fuse, you could get a carrier which would then break. The engineer's gone on to say the rewirable fuse cover is removed because of this.
The plug-in ones.
Yeah, he said the
one type 1 and 2.
Yeah. So they've just added that the rewirable fuse cover cover is removed because of this, would this fail in terms of IP rating on the front of the enclosure? I think very difficult without us being able to see. Obviously, you're not supposed to get a standard finger in, so that's 12.5 mil.
IP2X.
Yeah,
pretty standard finger. IP2X.
It's going to come down to IP ratings, isn't it? I mean, referring back to the more common 3036 boards, the old Wilex, where if you undid the skirt from around the old fuses, you could actually punch the top of the lid out, couldn't you, and fit the cover back on so it maintained a level of IP rating. But then we've got to ask the question: is how is the skirt fixed to the DB? Is it a thumb screw, or does it need a screwdriver to be removed? So there's a few
accessible
things
by the use of a key or a tool.
Yeah, there's a few things.
There's too many uncertainties on that question, really, isn't there? But
yeah, and through personal experience, you look at the
rating
capacity of some of these. They're relatively low. I think they start as low as 1K8, don't they? So really are they appropriate nowadays? You certainly shouldn't be, as a DIYer, you shouldn't be obtaining these things and just thinking, right, I'm going to pull out a 3036 revival fuse and push a plug-in MCB in because it's better, without doing the required tests. And, if we consider what's required of a modern-day fuse board, is a plug-in MCB really the way forward? It might not be compliant. You might feel it's compliant pushing one in because it's deemed to be more convenient than a fuse. You can just reset it if it pops off. But if we've got high fault current flowing and that device can't handle it, and the fault's still there on the circuit, and you're stood in front of the DB going to reset it, and that that breaker has handled a high fault current once, could it handle it again? Could it flash out? Could it burn the person operating?
In service or continued use? Yeah.
Yeah. These things don't see them too often now. Like I say, it's not for a DIY to fit them. If it's something that you want to do, get a professional to do, who can measure fault current, short circuit current. But I think a lot of contractors are just going to say to you, 1960s, 1970s DB. We're under the 18th edition wiring regulations now. We're not saying that 3036 boards are dangerous, but they could do with upgrading. There's much better things out there. So yeah, just some thoughts there for people to consider.
Yeah, but I think, like we said, on the IP rating, without being able to see, it would be very difficult.
100%.
But it's, as you say, it's the standard finger, so solid object, 12.5 mil diameter. That's what shouldn't be able to get into those gaps. But yeah, we do have to say 3036 fuses are still in 7671. They're not non-compliant, but as you said, certainly most domestic circuits now tend to have RCD protection. So 3036 fuses on their own often aren't compliant in regards new standard or the enhanced protection that's required with current 7671.
I think the other thing to mention as well, Sam, when we talk about these boards, I mean, there's still plenty of them out there in service. When these things were put in back in the 60s and the 70s, possibly the early 80s, installations weren't as complex as they are now. A lot of the appliances either didn't exist or they were relatively low loading. For instance, a 7.5 kilowatt shower nowadays, the norm seems to be 9.5, 10.8. Will the main switch of these boards handle these additional loads? And there is another consideration for possibly updating the consumer unit. A lot of the main switches are only rated at 60 amps. A lot of modern day installations, or the modern appliances in the kitchen, if, take Christmas Day, the worst case scenario, we could easily exceed 60 amps. So if your electrical contractor says to you, it's time for a board upgrade because of maybe inadequate circuit protection, maybe the main switch is undersized, it's advice that should be listened to. And I think this advice that I'm giving now is mainly for the general public. There's a lot of reasons to update your consumer unit. Just because it works doesn't mean to say it's still fit for continued use, maybe.
Yeah. Another question that's come in, DNO installing 80 amp main fuses. I'm finding that maximum demand calculations are coming in over, and I'm guessing they're meaning over the 80 amps, even on EICRs. What are we expected to do other than notify the DNO? Maximum demand calculations, some people consider it an art rather than a science, and depending upon what method you use, it might be the very simplistic 0.4 of the total. You might have a lot of extra in there just for a bit of conservatism. If it's possible, and if you've got the equipment, take a measurement, leave some data logging equipment on the installation so that you get a reasonable impact across different times of the day, and possibly seasonal variations as well, because if we've got things like electric heating, they'll have a big impact right now and perhaps wouldn't in the summer. So measurement is another way. To that installation that you might want to see if it is possible to upgrade the supply. It's not really sure what they're doing, can't really think of anything else. I don't know about what you guys think, if people have got concerns about maximum demand.
Yeah, well, the issue is that we're increasing loadings on everything, with electric vehicle charging being more prevalent now, and we're still looking into the DNO. And for a new supply on a domestic property, they're going to give you an 18.5 kilowatt supply. They're going to give you 80 amps and nothing more. And these calculations are, as you say, Sam, they're quite onerous and difficult to achieve without the use of data logging equipment. We're using the old rule of thumb value of 40%, the 0.4 of the total devices added together that you mentioned, which often yields something a little bit excessive, really, in my opinion. But it's a tricky one, maximum demand and diversity, as you've said. Data logging does give you a better indication over a period of time because you have peaks and troughs. It does help with EV lead, doesn't it, now, with the use of load monitoring equipment on EV, which has helped using CTs, etc.
We were actually talking about this on a site visit a few weeks ago with the local authority. I mean, you're absolutely right there, Stu. When we talk about EV equipment, we can program into it, what size of the cutout is, and with a load curtailment, we can actually manage and protect the service coming in. But based on looking at the loads in the consumer unit size of the MCBs, one of the things I was discussing with a contractor, this got brought up. They got a boiler circuit installed in 2.5, and whoever had fitted the DB put 20 amp breaker behind it, and it was feeding a combi boiler, which has got 3 amp fuse and a spare. And the guy was on about looking at the MCBs and getting a percentage, and I said, well, really, if we reduce the MCB to a 6 and possibly weigh it in 1 mil, the load hasn't actually changed, but the circuit design has, and it's going to have an impact on some of the calculations that you might employ just by looking at the sizes of the MCBs, which could, in this case, be over the top for the circuit. I'm not saying it's unsafe, but it could be more economical. So look at the loads, not just the ratings of the MCBs.
And that blows the 40% of the total device ratings in the board out of the water. So that's often the case, why I think it's excessive in a lot of instances. So
it's exactly the same as having a property with 2 ring mains and then saying, right, we're going to put the kitchen on its own ring main. We're not increasing the load of the house in any way, but we're separating the kitchen, which is putting an additional 32 amp MCB in, which is going to have an impact on the calculations.
Yeah, it's a tricky one, but
so I agree with Sam that load management is probably, putting some load management equipment on so we can, load monitoring equipment so we can take a look, a snapshot in time, what the installation is actually pulling. I think that's probably going to be more factual than taking a percentage of the MCB, Stu. I don't know how you sit with that.
Absolutely. Yeah.
Absolutely. And it doesn't have to be, I know we can't mention manufacturers, but I've got a very reasonable clamp meter that's got a min-max value, and when I had a real job, would leave it for a week in people's meter box to see what the actual maximum demand was, because it was far more accurate than any calculation, because I think now that there's quite a few accepted engineering calculation methods, but they all are very conservative, that they tend to go over the top, well, not over the top, but they tend to have a lot of safety factor, and they're risk averse, so that they tend to over exceed.
Absolutely.
Another good one that's come in from one of the engineers tonight, cable life expectancy. The SIBC, the engineer says, the SIBC document suggests 35 years, depending upon operational life, operating temperature, shorts, faults, overloads. How does one tell if a cable is past its expectancy? What are our thoughts there?
Insulation resistance. Yeah. Ultimately, if the cable's installed properly and it's in the right conditions and all the factors have been applied, it's running through thermal insulation, anything like that, shouldn't be overly exerted. And this is where the ICRs come into themselves. Is the installation fit for continued use? Other sides of wear and tear, thermal damage? Has it been installed properly in the first instance? But I think if we just look specifically at the cables, an insulation resistance test done properly between live conductors to earth at 500 volts, I think that's going to be the telltale sign if the readings are starting to lower somewhat.
Clear indicator of degradation in it if we're getting an expert. And then there'll be SM6N1 states a value above 1 megohm. But you would be expecting far more than that. And again, visual inspection as well, Lee, though. Visual inspection, as Sam was saying earlier, with respect to the S3036 boards and stuff, signs of thermal damage and visual inspection can tell a lot. The ICRs are the answer, really, aren't they? Done correctly, with sufficient IR testing carried out.
Yeah, we're all well experienced engineers, and I know I've gone to installations in the past in my sort of contracting days, and they've been like 40 years old, 45 years old, and they've been as good as the day they've gone in. Yeah. And then we've gone to more recent installations where the designer probably hasn't considered certain factors, and cables need replacing after a short space of time.
Well, that's right, and obviously it's subject to use as well, level of use, loadings, demand.
I remember back in the day, GU10 light fittings, and some contractors were putting a small amount of heat-resistant flex on the back of them. They were taking the twin and ear straight into the GU10, and you've got the heat dissipation up the cable. Over a few weeks, you might not see any impact, but if you went back after 12 months and looked at them, if they've been left on for a few hours, and the cable has started to bake, and that installation is probably a year old. So is it going to last 35 years if it's been installed incorrectly, without consideration for heat, for instance? No, it isn't. It's going to want rewiring a lot sooner. So good installation practices, good engineering practices are key with stuff like this. If you want your installation to last the test of time, think about putting maybe smaller circuits in, more circuits, but smaller circuits to limit the amount of current. Consider the factors of installation. Do the cables need, upgrading to a larger size?
Yes, why not?
And are we dressing the cables in as well? Take time, take care.
Also, Lee, to note modern properties, king span, thermal insulation, rammed into them, they can't breathe, buildings don't breathe anymore. They're sealed buildings.
Than ever.
So, all that is going to affect the lifespan of the installation when cables are run through that kind of material.
Yeah, and I think we all said insulation resistance is key. The other thing is to have a comparison. So if our insulation resistance is only 10 meg, but it's been 10 meg for the last 10 years, that tells you those cables are in good condition. So an insulation resistance measurement plus, if it's possible, a comparison. So if you've got the original installation certificate, or if you've got the previous condition reports, and then can compare those values to see how they are coming down, then that will give you an indication of how close you are, because you can see if it's been a huge drop since the last time, then there's obviously been some harsh usage, and that's sort of speeded up the degradation process. So insulation resistance is the key measurement about rewire and cable life, but a comparison would really help.
I think what I brought about values there, Sam, as well, this comes down to accurate reporting of installations. So when we're doing a condition report and we're doing any test, to be fair, make sure you write down the results that your meter's actually obtained. Don't round it up. Try, where possible, not to do a blanket test where you might put down 100 megohms for every circuit in the board. Try, where possible, to do it as an individual. Then if there is a low reading, we can identify what circuit that's on, which on a blanket test you wouldn't be able to do. And if the readings aren't accurately recorded, when we go back in 5 years, 10 years, or whatever the duration you specified is, we can actually see that the reading's falling. If we just put down a uniform 100 megohms down the certificate, that might not be accurate.
Yeah.
So be clear, be concise with what you write on the certificate. Accuracy on this is key, especially if we're monitoring a situation. Write down what the meter says.
Yeah. We've got a question which I've heard of before that's come in, and it's a little bit specialist in that. So it's an engineer that's working with UPS systems, and has said, has anyone ever come across a high ZE reading through a static switch of a UPS? In context, the engineer measured 0.3 ZE at the main DB from the circuit, but then through the isolators it suddenly increased to 1.41 ohms at the dB, which I'm guessing then was creating issues with it being higher than his overcurrent protective device's maximum ZS. When they've contacted the manufacturer, they just told them to bypass the UPS when doing the test, which again is something that I've heard before. Any experience in that area? I have to admit, it's something that one of my team is from the data center world and very particular with UPSs, so I'll certainly speak to him on it tomorrow. But have you guys had any experience of that?
Come across it in a data handling centre, Sam, a couple of years ago. I'm going to be honest with you, limited experience on this. I did advise the contractor to get in touch with the manufacturers, because ultimately we've got to be aware any advice and guidance we give, it's got to be factual. It's a bit of a difficult one, to be fair. I don't know what are your thoughts, Stu. Have you got any
only such, they're not with UPS, but such as trying to do any kind of live test results with VFDs and variable frequency drives? It's a no.
I'm not sure where to sit with because you want the results as it is in service, surely.
But there's other options. There's other options for limiting live testing anyway, isn't there? With electricity at work regs, so if all the other relevant tests are carried out for initial verification and R1 and R2.
Calculate ZS.
Yeah.
I'd be interested to know the answer, Sam, if you could ask your colleague, because he may have a better angle at it. But is it really necessary to obtain a ZS? Or could it be recorded and then marked on the EIC in the comments bit at the end that it's been ZS has been obtained by calculation from R1 and R2 and the ZDB or ZE, whichever is most appropriate?
It is acceptable to do it by calculation. We need to measure to make sure that there is a CPC if we're reliant on ADS. I seem to remember it was something about the fact that the way the UPS under operation works. And the previous caller had the exact same concerns as the engineer tonight, to sort of say, well, I'm being told to bypass the UPS, but under normal operation, the UPS is in circuit, so it won't be bypassed.
Yeah.
But I think
it shouldn't be bypassed.
Yeah, I think it's one of those things that it's the way that the device operates, the electronics associated with the fault detection circuit. It operates slightly differently to sort of the way that the thermal effect of a breaker operating under overcurrent. We'll dig into that, and if not at the next session, perhaps in a social media post or in one of the connections articles, do something that covers around that, because it is something that I've seen before.
This one's referred to. The electronics within the equipment themselves are introducing this impedance that in reality doesn't exist.
Yeah. Another engineer tonight has said that in terms about aging a cable, flexibility of the cable is a good indicator. Yeah, I think we'd all agree with that, but sometimes you can't actually demonstrate that if it's in containment or if it's in the fabric of the wall. So although we agree, it's not something we can often do. We'll take another one because it was one that comes up quite often. So we were asked, can they use a minor work certificate to certify work on more than one circuit? What's our thoughts there, Stu?
No, the intention's quite clear. We've had this conversation. I've had this conversation with a number of contractors on assessments who have used some, without mentioning names again, they've used a third-party software where they do a multiple minor work certificate. But 644.4.201 states that a minor works certificate shall be issued based on the model in Appendix 6, provided for each circuit that has been added or altered. So it's quite clear, as far as I'm concerned, that the details that you're recording on that minor works are relevant to that circuit that's been altered or extended or added to. So as much as it can be inconvenient to contractors for certain scenarios of work, multiple repairs in one building, this is a situation where I was questioned about the multiple minor works, and I said I don't believe it's compliant to 7671, convenient or not, because it's the information recorded on that's too blanketed, and there's various works carried out from various DBs. I mean, it's very clear, really, each circuit that has been added or altered. So no, the answer is it's a minor works for each alteration addition for each circuit that's been worked on.
It actually states on the certificate itself, doesn't it, like the notes for recipient, what it's supposed to be used for. Same with an EICR, same with an EIC. So the guidance is there for, obviously the end user, but also for the contractor as well.
Yeah.
Yeah.
And sticking with that theme, because it's almost related. Again, a common question that we get is, I've installed a new consumer unit as part of the remedial work resulting from a periodic inspection. Do I have to produce an installation certificate for the consumer unit as well, as all the test results, observations, etc. are already included on the EICR? What's our thoughts there? Can I get away with not doing an EIC?
No, it requires an EIC, unfortunately, due to other information that's recorded on the EIC with the design construction, who's inspected and tested it. And again, the guidance for recipients, as Lee mentioned before, the guidance for recipients clearly states that needs to be an electrical installation certificate based on the model forms in Appendix 6 need to be issued for the installation of a replacement of a distribution board or a consumer unit.
Yeah. Again,
you've selected and erected it, and you need to sign for that.
Exactly. Hence the design of the constructor and inspection test. The 644.1 refers. It's very clear in there.
Certifying your installation as opposed to reporting it, if that makes sense. You need to issue a certificate to demonstrate compliance with BS 7671.
Yeah, and departures, Lee. Departures aren't listed on the ICRs, are they? On the,
yeah,
you stating any departures that have been made, which if they're applicable.
So you're declaring extended liability to what the certificate actually covers, which is just the replacement of the consumer unit. Yeah, 100%. I think the other thing as well, you mentioned earlier on, Stu, about our software. When you do an EIC, at the end it asks you if the work's notifiable, which also replaces the consumer unit is, and you're going to click on yes, and it's going to transfer some of the data forward to the notification site, and one of those things is the certificate number. You don't get that facility with an EICR.
No, you don't. You'd have to do it as a separate thing.
Would sort of prompt you that you shouldn't be using it, if that makes sense.
Absolutely, because the certificate number, if you did try and put one in as a separate notification, would then refer back to an EICR certificate. It's incorrect.
Yeah.
Some contractors ask this question because they've done the EICR, but then changed the board. They don't want to. All they want to do is template the EICR they did originally and make it, remove the codings and set. So
if they've changed the board, I mean, the circuit layout no doubt has changed. The protective devices have potentially changed. So straight away, before we even get into test, we're generating a new certificate just based on the layout and the devices selected.
Absolutely, mate. Yeah. Certainly.
Yeah, it's Stuart. It's clear in black and white. 7671 replacement of a consumer unit requires an installation certificate. as you really said, there's lots of information that's required for an installation certificate which isn't on a condition report, because they're for two different purposes. So you'd be missing an awful lot of information, including the designer, including recommendations for the next inspection, including information about the installation comments. So yeah, it's imperative that you have to do, for compliance with 7671, you have to do an installation certificate, and you have to complete the declaration to say that your install complies with 7671, unless of course you're recording departures. Once again, we were talking before we started, this is always the quickest hour of our month, and we've flew through it again because there's a few things that I just want to talk to you about. So for anybody on the call tonight that's not currently certified by the NICEIC, please, if you're looking to get certified and become an NICEIC certified business, then please do go to the website. Likewise, if you're looking for any training, electrotechnical, renewable, emergency lighting, fire alarm, then again, we've got a training division which would be very useful. Really strong push at the moment on the experienced worker assessment for people that have been in the industry but perhaps didn't go down the apprenticeship route to start with. On upcoming events, we've actually got a live event at the moment. So if you're in the Sandown area, it's the final ELEX of 2025. It started today, it continues tomorrow. The NIC stand is up there. We're also doing a couple of presentations during the day around earthing and bonding of solar PV systems and commissioning and maintenance of solar PV systems. We're also supporting the IET industry forum. There's an open QA panel involving ourselves, NAPIT and the IET. So if you are in that area, please do come along. I'm actually going there myself tomorrow, so please do come along and say hello. And if you have got any burning questions that you haven't been able to get out tonight, we'll try and answer them at the event tomorrow. Other than that, before we go, just want to remind people of the next one. Again, it's the first Thursday of the month. It will be the last one for the year. So Thursday, the 4th of December, again at 8 o'clock, we'll have another live Q&A event where we'll try and answer people's questions. Thanks very much for those that contributed tonight and put their questions in the chat. Hopefully we got round to them. Apologies if we didn't get round to your question tonight, but we'll try and pick that up either next time or in one of the social media question and answers that we post out every week. So please, thank you for those. Any final words from yourself, Lee and Stuart?
No, we've enjoyed the evening, Sam. Thank you very much for asking us to take part. Hopefully we'll do another one shortly. Thank you for the contractors for popping the questions in. Yeah, no, it's good. Yeah. And there's been some people that have recognised you. You've both had people saying hello, and so I'll pass on the chat saying good evening and nice to see you. Been a worthwhile evening. Thanks very much. It is, we had the conversation earlier, didn't we, about if anybody ever tells you that they know everything, walk away, because our industry's too wide. It's too wide for anybody to know it all.
Too vast.
Yeah.
You'd have to live 4 lifetimes and study around the clock.
Yeah.
You still wouldn't
it's
know
one of
it
the
all.
good things about working for the NIC. There's then many people that we can turn to. If I haven't got some experience in a certain area, we've got Sam, we've got the entire technical support helpline personnel. We've got each other, haven't we, Stu? Because we all talk.
Apparently on the UPS systems league.
Yeah. We all sort of bounce off one another.
But we have got
strong at the end of the day if we don't know what.
We all help each other, as Sam says, and previously in these Q&As, that we're all here to help each other and support each other and help each other learn, and that's the positive good. It's great. It's great. So
every day I find I'm looking for the answer for something, and I find something else that I didn't know was there, and that sounds mad. I started looking in the book in the 15th edition, and I'm still seeing things that I've never seen before.
That's when I started, Sam, 15th, and it never, and you carry on opening these cans of worms forevermore.
But it's good. It's good. It hurts at first because you don't know the answer, but then you go away and you do your research and you find the answer, and then you're waiting for somebody to ask you the same question because now you've got that ammunition in your pocket. So no, it's a great industry. I'm going to a college next week, and that's one of the things that I'll be telling the apprentices and the learners at that college, that it is a fantastic industry with great opportunities. Really good.
Yeah, there is many good opportunities for young people if they want to get the skills and go into this industry.
I know something I say quite often when we're doing the assessments. Ultimately, the day of the assessment is very formal. It's us, the PDH, the QSs, and we go out on site. People are a little bit nervous and the likes. When we're out on site, sometimes we see apprentices. Please come across and say hello. If you've got any questions, we don't bite. We'll help you as well as we'll help the QS.
Absolutely.
Get involved, because one day, you might be a trainee today. One day, we might be assessing you as a QS. Make yourself known to us. Be familiar. Don't just, hide in the corner and think the NICEIC here. We don't want to get involved. Please come out and ask, any questions you've got.
Yeah.
Knowledge is key, as we've already said this evening.
Brilliant. Okay. Well, thank you very much, and look forward to seeing you all again next month. Thanks very much.
Cheers, Sam.
Bye. Cheerio.